that before we have completed electric field lines also. Now I want to discuss, as I've told you that it was a lengthy derivation, so I want to complete the derivation with you both. So we'll complete the derivation first. The derivation that we have regarding the electrical field line for the dipole moment. That's why field lines we have done first, and now we'll be coming to this topic here. Then torque and only flux will be left. Then that will complete the chapter. Now look here, class. Dipole moment when we are calculating, so electric field, see here, look in the camera. This is plus Q, this is minus Q. So when I draw a line joining the two charges like this, so if I draw these two, this is a straight line, right? So if this is a straight line, then any point over this is known as the axis, right? So any point on the axis will give us the axial line. So first we are trying to solve electric field on axial line on electric dipole. So electric dipole we have already studied in the last class, even a class before that. So that was P is equal to Q into 2A. So here also now look here over the screen. Plus Q is there, minus Q is there. Now just understand some variables because these terms will be there in every derivation, in the next derivation for the equatorial also. Now look, from the center of this dipole to the point P, we have this separation as R. Now when I'm calculating the electric field due to this minus Q, right, on this point P, so I have K, let me yell. I have this as K and this as small q. Now, what is the separation between minus Q and this point P? This is R and this is A. So, this becomes R plus A whole square. All right. And where will the field be directed? It's minus charge and here is my point. So, towards the charge, right? So, it is towards left. All right. Now come to the positive charge. Again KQ. Now divided by what is the separation? R was the total minus A. So this part which is left is R minus A. So what do we have now? KQ by R minus A whole square. Understood? See, I am saying again for minus Q. Minus Q is separated from the center by A and the center O is separated to point P by R. So R plus A, that gave me total distance between minus Q and point P, right? Then look at this plus Q. Plus Q, I want this gap. So this entire gap was R. This smaller gap was A. So R minus A gives this gap. This entire is R. I have deleted or erased A, so I am left with R minus. Now it's a positive charge, so it will be directed in the opposite direction. So that makes it towards right. It is directed towards the right. Now class, electric field. One is directed towards the left, other is directed towards the right. Now look here, E minus Q, E plus Q. So both are in opposite directions. Strictly we'll simply subtract it. So though we are adding the two vectors, but since they are making an angle of 180 degree, we are going to subtract it. So ultimately the resultant that we are getting for the final axial line, what are we getting? E plus Q, this is KQ by R minus A whole square minus. Why minus? Because both are in opposite direction. So when you are applying the superposition principle, they are in opposite direction. So we have to subtract them, right? And this is KQ by R plus A whole square. Now let's do one thing for the calculation purpose. Let us take KQ common. All right. If we take KQ common, we'll be left with 1 by R minus A whole square minus. Here we'll be left with R plus A whole square. Right? Now, you have two brackets with you, full-fledged brackets, but do not solve them as if you are solving a bracket. Think as if these are proper numbers. So how do you solve 1 by 2 minus 1 by 3? You take the LCM. That's the first step which we do. So here also we are going to apply this. So it is 1 by r minus a whole square minus 1 by r plus a whole square. So for us, r minus a square and r plus a whole square, these are like two numbers. So we'll be taking their LCM. If you take the LCM over here, so just simply subtract them. R plus a whole square minus r minus a whole square divided by r minus a whole square multiplied to r plus a whole square. Fine. Now, let us open the brackets. See class, here when we are solving this, KQ will be taken as common only. A plus B whole square. Remember your 8th class. A plus B whole square identity we'll use. So this becomes A square, that is R square, plus B square, that is A square, plus 2RA. Fine. We have opened the first bracket. Minus. Now see, this will be R square minus A square, R square plus A square minus 2RA. But since there is one more minus sign over here, so it will be multiplied again to the negative sign. So where I was to get R square, I'll be now getting minus R square. Where I was getting plus A square, I'll be getting minus A square. And where I was getting minus 2RA, now I'll be getting plus 2RA. Come to the denominator. A minus B square into A plus B square. Forget the square terms. Just see A minus B into A plus B. There is an identity A square minus B square, which is equal to A plus B multiplied to A minus B. That is the identity. So here also, since the identity is applying over here, we'll square the individual terms. R square minus A whole square, like this. All right. Now see, R square got cancelled, A square got cancelled. So ultimately we are left with 4AR. Why? 2 also got multiplied, right? 2RA plus 2RA gives us 4RA. So we have K into Q, which we have separated earlier only, and 2RA plus 2RA. That gives us 4RA divided by R square minus A square to the power whole square. Now look class, I'm just segregating two terms. It's the same thing which I have written already. A into R, fine. Q, instead of 4A, class, if I write 4A as 2 into 2A, both are the same. I can write the number as 4A, or I can write it as 2 into 2A. Both are the same. So I'm writing here 2A and here 2 divided by R square minus A square whole square. Now pay attention over here, class. Q into 2A. Is it similar to something which we have studied? Q into 2A. Anyone who can answer? Q into 2A. That's the dipole moment P. This is the dipole moment P. So finally, our answer will become 2kpr by r square minus a square to the power whole square. This is the formula for axial field, axial line of electric field. Now, one more thing. Okay, these direction part I'll tell you later. First, write it down till here. See, so this was the formula. E is equal to 2kpr by r square minus a square. Now, 2 points that I have to tell you in this only. Then we'll come to the equatorial line. On axial field, we have the same direction as that of the dipole. Fine. So minus q plus q and this point P. Now look, dipole's direction, we have studied that it is from negative to positive. This is the direction of dipole. So at the point when I am calculating the electric field, it will also be having the same direction, that is towards the right. That is towards the right. All right. Now, one more thing regarding the ideal dipole approximation. So, ideal dipole approximation basically says that we have the size of dipole which is very small. All right. The size of dipole is very small. So, it means when we have R and A and we are going to compare R and A. So, R is very, very much greater than A. What is R? The separation from the center of dipole to the point of calculation. So this separation is very, very huge as compared to this. So dipole becomes very small. The length of the dipole actually becomes very small. So if we have r square minus a square, that is almost equal to r square. It's like this is 1,000 and this is just 1. This is 1,000. This is huge. This is 1,000. This is just 1. So from 1,000 square, even if you're subtracting 1 square, then what will you get? You will ultimately be getting almost equal to 1,000 square only. 999 is almost equal to 1,000. Right? So r square minus a square will approximately be equal to r square. Will be equal to r square. So what you can do, r square minus a square, you can write it approximately equal to r square. So see, r square minus a square is approximately equal to r square. So what we'll do in the formula which we have obtained, that is 2kpr, this formula E is equal to 2kpr. Entire r square minus a square can now be replaced with just r square, right? This entire term can be replaced with r square minus a square. And then this square is left. So r square minus a square to the power square, right? So this is 2kpr by r to the power 4. 1r cancels. So we have the final formula of axial field. Axial of electric field as 2kp by r cube. What is important here is to mark the graph between electric field and the separation. That is, electric field is 1 by r cube times. All right. We'll come to this equatorial. First, copy till here. This direction and ideal dipole approximation. We'll be using ideal dipole approximation when r will be very much greater than a. In that case only, we'll be using ideal dipole approximation. So again, two things we have studied. On axial line, direction is same as that of dipole moment. Secondly, if dipole is very small, the size of dipole is very small, so E becomes equal to 2kp by r. That's it. Write down these 2 points, then I'll start with equatorial line. Yes, class. Now come to electric field on the equatorial line of a dipole. Now, class, what is an equatorial line? Equatorial line is basically a point which is 90° to the dipole. So minus q and plus q. And now from the center to this point of calculation, again we are taking r. All right. Now look, electric field due to this positive charge, it will be away E plus Q, and due to this negative charge, it will be moving towards the charge E minus Q, right? Now look, I have to resolve the vectors. Wait. This will be theta. This will also be theta. Why? See, this is theta. This is 90°. 90 minus theta. Total is 90. So theta. And both are equal angle. So this is also theta because this is bisecting. Otherwise, you can directly also see, even if you are not making this calculation, this is a line parallel to this line. So these are alternate angles. All right, alternate angles. These are corresponding angles. That's it. What you have to remember. These are alternate angles. Fine. Now what we have to do? We have to resolve the vectors. Let's resolve these vectors. This way, this is E plus Q. Cos theta, perpendicular, it is E plus Q sine theta. E minus Q, this is E minus Q cos theta. Perpendicular, it is E minus Q sine theta. Right? Now look, class. When we'll be writing the values, this is K, Q divided by. Now let us look at the separation. Let us look at the separation. What is this separation? This is R. Look. This is R. This is A. This is R. This is A. So when we are calculating, so this will be under root R square plus A square using the Pythagoras theorem. So that is our separation which is required. So this becomes under root R square plus A square whole square. So this becomes KQ by R square plus A square. And it will be directed towards the charge, means towards minus Q, because it is a negative charge. And similarly, when we'll be writing about this E plus Q, so it will be K, Q, same separation, R square plus A square to the power whole square equal to KQ by R square plus A square. But this time, this is away from plus Q. So this is away from plus Q. Right? This is away from plus Q. Now, class, have a look at this. This sine theta, both are in opposite direction. So they'll cancel themselves. So E plus Q sine theta minus E plus Q sine theta. Both are same. They'll cancel each other and make it 0. But what about cos theta? Both the cos theta, they are getting added in the same direction. So this way, it will be twice. It will be added. So it becomes 2E cos theta. Now, class, our task is to find out what is this E, what is this cos theta. That's it. And that will give us the net electric field because Y is already 0. X we are calculating. So net will be whatever answer we are getting through it. Now, class, one thing. In this triangle, I'm drawing this triangle separately. I'm drawing this triangle separately. So this was R. This is A. This was theta. So, and this is under root R square plus A square. So if I am writing cos theta is equal to B by H. So here cos theta will be equal to A by H. Hypotenuse is under root R square plus A square, right? Now what will be the value? I have cos theta with me and I have electric field with me. So see, net electric field will be 2. What is electric field? K cube by R square plus A square. What is cos theta? Cos theta is A by under root R square plus A square. Now class, if we write this will be equal to C. K into Q into 2A. So K into Q into 2A means P C Q into 2A divided by this is to the power 1, this is to the power half. Half plus 1 becomes 3 by, so this is to the power 3 by 2. So final formula of electric field at the equatorial point, it is equal to K into C. This term, this is what? This is the dipole moment. So this is K into P by R square plus A square to the power 3 by 2. That is the formula. Write down the derivation first, and again I'll tell you about its direction and ideal dipole approximation. And class, it's a lengthy derivation that comes. One more thing, class, one more thing. If you do not know about this, see class, when we have to resolve the vectors, this is a vector, suppose this is a vector A, and this is, or let me take a more random direction. Suppose this is vector A and I have to resolve. So this becomes A cos theta and the perpendicular one becomes A sin theta. Write it down. Any doubts, please let me know in between. Okay, class. Now regarding the direction of the equatorial line. So in axial line, we had seen that the direction was same as that of the axial line, right? Dipole moment. But here we'll have the opposite direction. So look, if the dipole's direction, let's say the dipole's direction from negative to positive, so electric field will be directed towards the left. This is the difference that will be coming. Now regarding ideal dipole approximation, R is very much greater than A. So R square plus A square is almost equal to R square. Now let's see here. We have the derivation as Kp by R square plus A square. See here. In this we have R square plus A square to the power 3 by 2. R square plus A square to the power 3 by 2. So this becomes Kp by, see, R square plus A square. It becomes R square to the power 3 by 2. Half will be cancelled. So Kp by R cube. Again, look at the variation of electric field and radius. It varies R cube. So what are the differences that we'll see? Formula for electric field at the axial line, this is 2 Kp by R cube. And formula of equatorial line, this is minus Kp. Now why minus? Because minus sign is showing that this is in the opposite direction. This minus sign is just showing that it is in the opposite direction. Now if I take the ratio of both of these, E axial by equatorial, I'll get 2. So this is important. Sometimes in a 2-marker question it comes. Write it, then I show you this question. First write down this, then we'll come to the question. Okay, class, so see, this is E1, this is E2. Why? Because this point A is lying on the axis of P1, so it becomes E1. And this point is again lying on the axis of P2. So this E2 is also axial. So since both of these are axial, we are taking the same direction as that of dipole. Now you know E is equal to K P1 by R1 cube I cap plus K P2 by R2 whole cube J cap. That's the answer. Write it. Okay, see here we have to calculate the electric field due to dipole which is having length, everything is mentioned, and equatorial point. So see, we have already studied the formula of electric field is Kp by r square plus a square to the power 3 by 2. So see, K is 9 into 10 to the power 9, dipole moment, charge multiplied to the separation. So what is the charge? Charge is 10 to the power minus 6 by separation. Separation is 10 centimeters. So 10 into 10 to the power minus 2 divided by r square. What is r? R is 12 centimeters. So 12 into 10 to the power minus 2 whole square plus a is 5 into 10 to the power minus 2. See, if 2a is 10, so a will be 5 only to the power 3 by 2. You'll solve this, you'll get your answer, and that completes with the topic. Quickly write it and text me, done class.